All right, we are moving on to question number 34 on our Algebra 1 practice test for Florida Best Standards. Did I enter in 33? Yep, I did. And we're on 34. Okay. The equation of a linear function Q and a table of values of a linear function R are shown. Which statement correctly compares the slopes and y-intercepts of the two functions? So we need to look at function Q, find the slope, and the y-intercept. And function R, look for the slope and the y-intercept. So when I'm looking here, we know we got linear functions. I'm looking at this formula, and this formula is on the reference sheet. Which one does it look the most like? And to me, it looks the most like the first one. Y equals mx plus b. And the name of this form of a linear function is called slope-intercept.
If you are still here,
y equals mx plus b, and this is called slope-intercept form. And knowing that it's called slope-intercept form helps you to remember that that letter m is the slope and that the y-intercept is the letter b. So here, your slope is the 2, and your y-intercept is the -1. And then when we're looking at the table, you have values that are x function or x, y. And right away, what is a y-intercept? Y-intercept, you ask yourself the question, what is y when x is 0? And when x is 0, the y-intercept is -2. They told you there. And then what is the slope? So as x goes to the right by 1, your slope is going up from -2 to 4 is up 6. From 4 to 10, up 6. From 10 to 16, up 6. Is going up 6. So our slope 6 divided by 1 is 6. Now we can see which one compares the slopes and y-intercepts correctly. R has a lesser y-intercept. This was function R, and its y-intercept is -2. -2 is less than Q's y-intercept, which is -1, so that's true. R has a lesser y-intercept, not greater, because -2 is less than -1. And the slope is how many times greater than Q? The slope. How do we get from 2 to 6? 2 times 2 would be 4, not 6. But 2 times 3 is 6. So this answer choice is correct. And Only 31% of students got this question correct in the state of Florida. I feel like that could have been a little higher. And some practice you can find in IXL that's similar to this type of question. You have lesson EA8, and you have IXL lesson GD7. And if your school district has paid for you to have a free IXL account, like, I'd use it. That was number 34, was B. Question number 35 says, a system of inequalities is given. Which graph represents the solution set? And rather than looking at the answer choices, I'm just going to graph it really fast because these are kind of like fast and fun for me to graph them. I like these. I'm going to make the first one yellow. X is greater than or equal to 5. So I'll make my line yellow. So I'm going to find where X is 5, and that's about over here. And X is always 5. Solid line, because we have the line underneath it. X is greater than or equal to 5. So I would shade in this direction for that inequality. And then I'm going to make the next one blue. And I'll make the line blue. Y is less than -3. Where's y is -3? It's about down here. We don't have the or equal to, so it gets a dotted line. And y is less than, so we shade below. And what is your answer to a system of inequalities? It's this stuff here that got shaded twice, needs to be shaded, and your lines need to be in the right spot. And I see a solid line on 5, a dotted line on y is -3, and only the green part got shaded on answer choice A because answer choice A is correct. And 41% of students in Florida got this question right. And you can practice this in IXL at lesson S, G, H. Number 35 is A. And, I got time. Question number 36 says an equation is shown. What are the two solutions to the equation? And this is another one of algebra's greatest hits. We're gonna solve for x. We've got x squared minus 15x equals -14. And I would love to combine like terms, but we don't have any. So I'm just going to get everything to one side of the equal sign so I can get a 0. So let's add 14 to both sides to give us x squared minus 15x plus 14 equals 0. And then right here, something I forgot to show my students in class. You can use something from your reference sheet here. You could use your quadratic formula because now we have something that looks like ax squared plus bx plus c, and we put it equal to 0 because we want to find the zeros, right? We want to factor it out. And you could use your quadratic formula right here for this question to factor it out. In class, we factored it out a different way. We said, what can we put in for x? That's numbers that multiply to 14 and add up to negative 15. And we said x is negative 1 and negative 14. When you multiply them, you get positive 14. And when you add them up, you would get that negative 15. I'm tempted to go in and put the quadratic formula over here. Let me see, number 36. Only 19% of students got this question right. So I feel like going from this step to this step might be a big jump for some of our Algebra 1 students. Hoo, hoo, hoo. From right here though, I can say, how do we make x minus 1 be equal to 0? We make x 1. How do we make x minus 14 be equal to 0? We make x be 14. So that's the traditional algebra way to solve that. But on your test, you are given the quadratic formula, which says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals, you don't have to type in. It's a big old fraction, and on the top, it's negative b plus or minus the square root of, how did I get a 2 for b? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, there's the formula from the reference sheet. I just typed it in. And then look over here. What number is a? It's 1. What's 2 times 1? 1. What's 2 times 1? 2. And if a is 1, what's 4 times 1? It's 4. So the a kind of just disappears because we multiplied by 1. And then your b, you've got negative 15. So change that b to a negative 15. Negative 15. And c, you have 14. And look at that. We get 14. And then if you change that plus right there to a minus, you get your other answer, 1, by using the quadratic formula. And you can just type it all in at one time on your Desmos scientific calculator. You don't have to work out the quadratic formula step by step. As just as long as you set it up correct, you're good to go on a question like that. So I feel like if more students would have practiced using the embedded Desmos calculator, a lot more than 19% of students would have got question number 36 correct. And I'm going to end this here because it's time for me to leave school. And I will try to finish this up later tonight. If people are studying, I'll get back and get the last few questions on here for you. I am rooting for you guys.